My dear friends, welcome back to B Spice. In this session, under Back to Basics, we'll focus on RS-232 versus RS-485. So, before going into the details, we'll focus on the intro. As you know, RS-232 and RS-485 are the standard for the data cables. This one we know. So to exchange data between nodes on a network, most commonly used tools are drivers and receivers. This also we know. So the point is, it is difficult to set up a network with smooth data transfer because as there is noise, ground level differences, mismatch of impedance, and other dangers also there. So Electronic Industry Association, EIA, and Telecommunication Industries Association, TIA, set up the standard for the production of cables and other tools used in setting up of network. Okay. So this standards ensures that compatibility between devices provided by different manufacturers and allows for better and smooth transfer of data over long routes and of course for improved data rates. Okay. So you may ask the question, what is this RS? Yes, RS stands for recommended standards, hence RS 232 and RS 485. But nowadays the system adopted prefix the EIA instead of RS. That is also you take a note. Right, that is about the intro. Okay, now we'll talk about data transfer. Data transfer is broadly classified as single-ended and differential. What is the single-ended? How it works? Okay. Single-ended data transmission uses one wire to carry the signal and another wire that is ground for a reference. So the receiver measures the voltage difference between the signal wire and the ground. This is the point, single-ended. I repeat again, friends. Single-ended data transmission use one wire to carry the signal and another wire as a reference. So the receiver measures the voltage difference between single wire and the ground. So when you talk about the advantage, it's simple, easier to implement, and of course, cost effective, less expensive. When you talk about the disadvantage, yeah, noise, okay, prone to electrical noise and limited distance. Okay, as simple as that. That is about the single-ended. Now, differential. Differential data transmission use two wires. One with carrying the original signal and other carrying an inverted version of the signal. So the receiver measures the difference, voltage difference between two signals, cancelling out any common mode noises. So that is the beauty of differential. So of course, when we talk about advantages, it is noise immunity, excellent at rejecting noise, okay, and other interferences. And of course, improved signal integrity, okay, and reduced electromagnetic interference. And when you talk about disadvantage, of course, complex because it requires more wire and sophisticated, hardware, all these aspects. Okay, let us not go into those details. So now coming back to this, RS-232, which was meant for single-ended, was launched in 1962. Okay, and despite its limitation, right, we have been using this even till today, right? So RS-232 allows for a data transfer at relatively slow speeds. Okay, so slow speeds in the sense up to 20K bits per second. Okay, and short distances up to 50 feet. So when data transfer has to take place over long distances and also at a faster rate, single end method proved to be inefficient, meaning it's not going to be helpful. Okay, that is a point. So this is the time when differential data transmission comes into picture. because it provides a superior performance as we discussed just now, right? So these signals negate the bad effects of ground shifts and induced noise signals on the network, right? So for that, RS422 was produced to meet such requirements. After 232, 422 was produced. But over time, it has been found that RS422 cannot be used to construct a true multi-point network. So that is a point, friends. So that is why, to answer all this, finally, RS485 entered, which meets all the requirements of a truly multi-point network. So RS485 specifies up to 32 drivers and 32 receivers on a single bus. Just imagine the advantage. So RS485 drivers are also capable of handling the problem of data collision and bus fault conditions. Okay. So there are many differences, friends, between 232 and 485. And of course, signal mode is prominent among them. And RS485 is balanced and RS232 is not balanced. We will see the comprehensive comparison now. Okay. So I have taken a few items for comparison. One is mode of operation, of course, single-ended and differential. Okay. So we talked about this earlier. And number of drivers and receiver. One driver and one receiver for 232 and 485, 32 drivers and 32 receivers. Maximum cable length for 232 is 50 feet only, but whereas for 485, we can go up to 4,000 feet. And data rate is only 20 kb per s for 232, whereas for RS485 we can go up to 10 Mbps megabyte per second. And driver output voltage plus or minus 25 volt for 232, and for 485 it is minus 7 to plus 12 volt. And signal level with minimum load minus 5 volt to 15 plus or minus 15 for 232, and this 485 plus or minus 1.5 volt. Then signal level unloaded max, that is plus or minus 225 volt, and for 485 it is plus or minus 6 volt. Okay. Then few more to add on. Driver load impedance 3K to 7K for 232 and 54 for 485. And receiver input voltage range plus or minus 15 volt. And here for 485 it is minus 7 to plus 12 volt. And receiver input sensitivity plus or minus 3 volt. And for 485 it is plus or minus 200 millivolt. And receiver input resistance 3K to 7K. And this guy 485 has more than 12K. That's all, friends. I hope you got some insights on this RS485 and 232. So thanks for watching. I seek all your support, friends. Your support is very important. So this is the only request. Okay. Just always think behind every work, there is a homework. There is a time spent. Okay. So yeah, that's it. Thank you. See you in the next video. Take care. Bye-bye.